Right, I'd like to continue with this example. We were asked to find all the possible rational zeros of this polynomial, and we use the rational zeros theorem to do that. We know that all the possible rational zeros, since this polynomial qualifies as integer coefficients, have to be such that the numerator is a factor of the constant term, and the denominator of the possible rational zero is a factor of the leading coefficient. So this gives us a list by which we can check to see if these are zero of the polynomial. All right, so let's go ahead and find the zeros of this polynomial. Okay, there's only 8 to check, so we can just go down the list here. Let's start with 1. So we use synthetic division. We have x cubed is coefficient of 1. X squared is not there, so 0. X to the first, -7, and -6. All right, so what we'll want to do now is to bring down the 1, multiply, add, multiply, add, multiply, and add. Okay, the remainder is not 0, so we know that 1 is not a 0. Okay, let's try -1. All right, so 1, 0, -7, -6. Bring down the 1, multiply, -1. Bring down the 1, multiply, add, -6, multiply, 6, -6 plus 6 is 0. Aha. So we found a 0, 0 of -1. All right, and now what's left? Well, this term that's left is of the form x squared minus x plus 6. And so we've effectively written this polynomial as x plus 1, x minus -1, times x squared minus x minus 6. Minus 6. That's what it is. All right. Okay, and now what we could do is we could take this and run through more zeros, but since it's a quadratic, we'll try to factor it. I believe it factors. If not, you could use the quadratic formula on it, or you could continue to plug in some zeros here. So we have x looks like -3, and x, plus 2. Let's double check that. So x times x is x squared, x times 2 is 2x, minus 3x is -x, -3 times 2 is -6. All right, so there we go. We've got zeros of -1, 3, and -2.